pretty much everything that our group really focuses on tries to look at problems where we feel we know very little about what we need to solve that problem. So in our group, we really emphasize challenges both at the technology level and the basic science level, where we feel we have about 5% of the knowledge, and we need to fill in that rest of that 85 or 90%, so we can get on the learning curve towards reducing cost, increasing efficiency, and ultimately making deployable technology. What we're a little bit more reluctant to get involved with is those things where we're already 95% of the way there, because we think that the opportunities for really transformative new technology is less so when so much of it has already been figured out. We've gotten a lot of traction from big oil and gas players, and so our CO2 conversion work is supported both by, for example, the Air Force, Office of Scientific Research, as well as the Department of Energy, as well as also different areas of it by ExxonMobil, for example. Right? And so we've been incredibly excited by the enthusiasm with which industrial stakeholders are recognizing the importance of these problems and recognizing the need to move away from sort of the incremental advances that have so far been kind of the modus operandi historically, and invest in the basic science that's done at MIT in order to come up with the sort of next generation disruptive technologies. We're only trying to change how 1/3 of the global economy works. So, unsurprisingly, that is a long range and tall order, and we play, we think, a very important piece of that. I think the other thing that I often, when we have conversations with industrial stakeholders about is to recognize that the road from new science, new technology, ultimately to the market, is necessarily a twisty and windy road. And that is inherently, it's almost a requisite, it almost has to be there because we are dealing ultimately with upending and changing the way many legacy industries may operate. If we want to make fuels that have no carbon balance to them, it means that we're going to have to radically alter how we do things. And that radical alteration means that there need to be many, many partners in that process of innovation. It's not the process that goes from the basic science all the way to deployment of a technology and ultimately its success in the marketplace is something that will start perhaps in our laboratories, but will very quickly need also input from engineers, from economists, from policymakers, from all of the pieces that need to be there in order to make sure that that has the right ecosystem, both technology-wise, societally, economically, to be able to thrive ultimately. And so we see ourselves as kind of the foot soldiers at the very early part of that problem. And we're very excited about the fact that when we have those new devices, new technologies, new basic chemistries, we're within an ecosystem where all the other players are there to be able to very rapidly move that forward along the innovation chain. So let me just say it in a broader way, right? That ultimately we're motivated to do a lot of our work because we think there's an enormous opportunity to be able to take legacy energy systems and legacy chemical processes and make them far more sustainable and environmentally friendly. And that really impacts that ecosystem all across the chain. And so one other area we're very excited about is the prospect of using electrochemical technologies and renewable electricity to, for example, clean up polluted water streams, right? We're thinking about technologies that allow us to take renewable electricity and convert atmospheric gases like O2 into disinfectants like hydrogen peroxide. Technologies like that would be really transformative in terms of being able to open the door in a distributed fashion to environmental remediation, environmental water quality efforts that relate ultimately to a much more sustainable operation of life processes that exist really everywhere in the globe. And the other thing I should also say, right, is that a lot of the technologies that we develop also serve in many respects a way of sort of democratizing the things that we take for granted here in the US, in developed economies. Right? We don't have, here in Cambridge, Massachusetts, we don't have to worry about adequate supplies with regard to sanitation and clean drinking water. But in many parts of the world, those are enormous challenges, and they ultimately relate also to enormous societal pressures. And we really think that because the sun shines everywhere and the wind blows everywhere in some respects on Earth, the ability to deploy that renewable electricity to do chemistry that's in the service of these desperate needs allows ultimately a democratization of that technology and a democratization of the societal good that can come from that, as well as the environmental benefits that arise from that. And so that's sort of the underlying mission. It's not simply a question of kind of developing technology for technology's sake. We really feel that a rethinking of how you use energy and transform energy between one form or another would allow us to be able to eventually develop a far more equitable way of supporting societies all across the globe.